Welcome to MRL. In this learning session, we'll be learning about set theory and the different terms that are related to set theory. Now, what is a set? A set is a collection of well-defined and distinct objects. A set of vowels of English alphabets, a set of natural numbers, a set of even numbers are examples of a set. Now, elements of a set are the members of a set. Now, a collection of beautiful flowers is not a set because the members are or elements are not well defined. Representation of a set: the elements of a set are enclosed in braces and the set as a whole is denoted by capital alphabets. Again, I'll repeat: the elements of a set are enclosed in braces and the set as a whole is denoted by capital alphabets A, B, C, etc. A is equal to braces, and within the braces are placed the elements of a set. Method of representing a set. A set is represented by different methods. We have got the description method, roster method, and rule method. In the description method, in this method, a well-defined statement describing the elements of the set is enclosed in curly brackets or braces. For example, A is equal to, within the braces, letters of English alphabets. Now, one more example: B is equal to, within the braces, days of the week. So, this is the description method. In the roster method, or also called as tabular method, in this method the actual elements of the set are enclosed within curly brackets. For example, A is equal to, within the braces, 1, 2, 3, 4, 5, 6. They are the elements or the members of the set. And B is equal to, within the bracket, Monday, Tuesday, Wednesday, Thursday, and that is again one more set expressed in roster method. Then we have the rule method or the set builder method. In this method, a variable x representing every element of the set with the condition or property of the element is enclosed within curly brackets. Now, for example, set A is equal to, within the brackets, within the braces, x is such that x is such that x is a natural number and x is less than 10. A very method of representing it in set builder method. And B is equal to, within the braces, x is such that x is a month of the year, that is remember that. So this is read as x is such that x is a month of the year, or instead of two dots we can put a slash also, and it is read as x is such that x is dash dash and dot dot. Remember that. Let us take a few examples here. In the descriptive, roster, and rule method. In the descriptive, if you write set of all vowels in English alphabets is a set, then in the roster method the same can be written as, within the braces, A, E, I, O, U, writing the elements, and in rule method within the braces we can write x is such that x is a vowel in English alphabet. The second example: the set of even integers less than 13. The set of even integers less than 13 is the descriptive method. In the roster method, within the braces, we write 2, 4, 6, 8, 10, 12, which are the integers less than 13, and they are even integers. Then in the rule method, within the braces, we write x is such that x is an even positive integer and x is less than 13. The set of all squares less than 40 is the descriptive method, and in the roster method within the braces we have 0, 1, 4, 9, 16, 25, 36 because they are all squares less than 40, and in the rule method we write within the braces x is such that x is a square because all the numbers are squares and x is less than 40. So this is how we can represent the sets by descriptive method, roster method, and rule method. Remember that. Now there are different types of sets. We have got finite set, infinite set, empty set, singleton set, equivalent sets, equal sets, disjoint sets, overlapping sets, universal set, subset, proper subset, and power set. So let us understand these sets one by one. Now let us go with a finite set first. A set containing countable number of elements or finite elements is called a finite set. So if the set contains finite elements or countable elements, then it is a finite set. For example, A is equal to, within the braces, 1, 2, 3. There are only 3 elements here, and therefore it is a finite set, and therefore the number of elements is represented as Na is equal to 3. Now the same thing can be also we can write what you call in the set builder method Okay, now the method is set B is equal to x is such that x is an even number and x is less than 10. So therefore these both are finite sets here, because this is a set of even numbers and the even numbers are less than 10, therefore finite set. Now infinite set, a set containing uncountable or infinite number of elements, is called an infinite set. For example, n is equal to 1 2 3 4 dot 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 is an infinite set because it is a set where the elements are infinite or uncountable, and the consecutive dots called ellipses indicates infinite members, and z is equal to 0 plus minus 1 plus minus 2 plus minus 3 dot 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 again is an infinite set. Remember that. Then we have the empty set, also known as null set or void set. A set containing no element is called an empty set, and an empty set is denoted by a symbol psi, or just putting two braces with no element within it. And also, now let us take one example here. A is equal to within the braces x is such that x is a prime number, is a prime even number rather. X is such that x is a prime even number and x is less than 3. Prime even number and x is less than 3. That means the number which is a prime number and also even number is only 2, and therefore is x is greater than 3. Please understand again here, x is such that x is a prime even number, x is greater than 3, and there is no number which is an even number and a prime number, therefore it is a null set. And B is equal to a set of odd numbers that are multiples of 2. A set of odd numbers that are multiples of 2. There cannot be an odd number which is a multiple of 2, therefore it is an empty set. Now empty set is a part of subset or every set. Remember this, empty set is a part of subset or subset is a part of every set or a subset of every set. Singleton set, a set containing only one element is called singleton set. A is equal to, within brackets braces we have phi, it is one element, therefore it is a singleton set. Then we have equivalent sets, two sets having same count of elements or are known as equivalent sets. For example, A is equal to 1 to 3, there are 3 elements here. B is equal to ABC, there are 3 elements here. NA is equal to 3 and B is equal to 3, and therefore these two sets are equivalent sets and represented symbolically that set A, that is NA is equal to NA is equal to NB, and therefore set A and B are equivalent sets. Remember that. Now equal sets, two sets are equal if they have the same elements. Now here you have a set A is equal to 1 2 3 and we have a set B is equal to 3 2 1. 1 2 3 and 3 2 1 are the same elements, although the order may be different. Therefore set A and B have same elements, so therefore the sets A and B are equal sets. Two sets are called disjoint sets if they have no common elements. We have a set A here 1 2 3, B is equal to 5 6 7. None of the elements are common here, therefore they are disjoint sets. Now two sets are called as overlapping if all the elements of one are present in the other. For example, we have a set here, a set of natural numbers, and we have a set B, set of whole numbers. All the natural numbers are present in whole numbers, therefore the set A overlaps set B, and therefore they are called as overlapping sets. Then a set that contains all the elements of sets under consideration is called a universal set. It is denoted by U. It is also called as a main set. The other two sets under consideration are subsets of U. If the elements of all sets are students of a school, then they form the subsets of all the students of school set called as universal set. So remember, universal set is denoted by U. It is a universal set because it contains all the members of every subset which can be formed out of that universal set. Now subset, if A and B are any two sets, the elements of A are the elements of B, then A is a subset of B. For example, A is equal to 1 to 3 is a set, B is another set, 1 2 3 4 5 6 are the elements of set B. Now we find the sets of A are there within the set of A, are there in set B, and therefore set A is subset of B, and the symbol of subset is, this is the symbol of subset, and remember that. So therefore we say that A is subset of B. Okay, the next proper subset. A set A is a proper subset of B if B has at least one element more than A. Now you have a set A here 1 2, we have a set B 1 2 3 here. Now B contains one element more than A, therefore A is a proper subset of B. A collection of all subsets of a given set is a power set. Now if A is 1 2 3, then subsets of A are the empty set, set, then we have a set with element 1, set with element 2, 3, 1, 2, 1, 3, 2, 3 and 1, 2, 3. These are all subsets of set A, and therefore the power set of A is equal to again one more set which contains all these subsets. So the number of elements of the power set, if you count 1, 2, 3, 4, 5, 6, 7, 8, and therefore there are 8. Therefore there were here 3 elements, therefore 2 raised to 3 is 8. That is what is the formula used here. The number of elements of PA is equal to 8, or 8 2 is 2 raised to 3. Therefore if NA has 3 elements, then the power set will have the 2 raised to 3 elements. Remember that. If the number of elements are n, then the number of elements of the power set will be 2 raised to n. Remember that. In the next learning session, we'll continue to learn about sets and study about the operations on sets. Until then, learn the important basics which we have learned in the first part. In the second part, we'll be learning about the operations on sets. Thank you.